Okay, now let's talk about how we can compute the global minimum variance portfolio in Matlab. And for this purpose, let me give you an example. And in this example, I'm going to use some values for this expected returns and the covariances. So let me give you this example here. So suppose we have three assets in our economy, and these are the expected returns for asset 1, 2, and 3 that are given. So these are, for example, asset 1 has an annual return of 5%, asset 2 has an annual return of 8%, and the last one 10%. And suppose we also calculated the covariances of these three stocks from some historical data, and we assume these are already calculated here. Okay, so if I have these values now, remember in our global minimum variance portfolio, what we did is we applied the Lagrangian method, and we have written the problem in this form here as equation 41, and we have written down our first order conditions. So once we get the first order conditions, actually what we have is a system of linear equations, and we know how to handle systems of linear equations in this chapter. So how can we write this first order conditions as a system of linear equations? You can see that the first thing here is actually a matrix times this vector of investment weights m, and then you have this lambda, which is a scalar, but it is multiplied with every element of the vector of 1s. So actually here you have a column vector 3 by 1, and on the right hand side these first order conditions are equal to 0. So this is a vector of zeros here, and you can see that we have the m times the vector of 1s, and we have 0 times lambda, and right hand side you have this scalar, which is just a scalar 1. Okay, so how do we write this system of equations? First of all, let's try to write our coefficient matrix here, which is given by this term. So this can be written, so remember we have the covariance matrix, and I want to multiply every element of this by 2. And then I'm going to have this vector of 1s, which is a column vector. We have 3 stocks, so I need to have 3 by 1. And then I have the transpose of it. So I'm going to have 1s, 1 by 3. And then I can write the 0, which is a scalar in this case. Okay, so let's try this and see if we make any mistakes. Looks like everything is okay. So you can see that we have the vector of 1s here, we have the row vector because of the transpose over here, and we have the scalar 1. So our coefficient matrix is fine. And what about the right hand side of this system? Now notice that we have the vector, column vector of zeros, so it's going to be 3 by 1, and then the next thing is going to be a scalar, which is 1. So you can see that we have also defined the right hand side of this system of linear equations. So now we can easily solve this in different ways. One thing you can do if you like to do direct inversion is take the inverse A times B. Okay, this is one way to solve the system of equations, although this is not computationally efficient as we discussed before, but it will still give us the right answer as expected. But we can compare this now with alternatives. We can use the Gaussian elimination by this backslash operator. So this is the Gaussian elimination now, and we can verify that we get the same results. And notice that, by the way, the first 3 terms are what we are looking for here, because these are the portfolio weights, and actually you can verify whether they add up to 1 or not by taking the sum of the first 3 terms, and we can verify that the sum equals to 1. Okay, so this is how we can solve a system of linear equations for computing the global minimum variance portfolio in Matlab.